Today we are going to discuss about the introduction to MATLAB. Throughout this tutorial, the primary objective is to help you learn quickly the 4 steps. The emphasis here is learning by doing. Therefore, the best way to learn is by trying it yourself. Working through the examples will give you a feel for the way that MATLAB operates. Now we start with the introduction. First of all, what is MATLAB? As the name suggests, MATLAB stands for Matrix Laboratory. It was written originally to provide easy access to matrix software developed by LinPack and EISPack projects, where LinPack is Linear System Package and EISPack is Eigen System Package. MATLAB is a high-performance language for technical computing. It integrates computation, visualization, and programming environment. Furthermore, MATLAB is a modern programming language environment. It has sophisticated data structures, contains built-in editing and debugging tools, and supports object-oriented programming. These factors make MATLAB an excellent tool for teaching as well as research. Now, what are the key features of MATLAB? It is a high-level language for numerical computation, visualization, and application development. It also provides an interactive environment for iterative exploration, design, and problem solving. It provides built-in graphics for visualizing data and tools for creating custom plots. It provides tools for building applications with custom graphical interfaces. It provides functions for integrating MATLAB-based algorithms with external applications and languages such as C, Java, .NET, and Microsoft Excel. It has many advantages compared to conventional computer languages for solving technical problems. It is an interactive system whose basic data element is an array that does not require dimensioning. And it has powerful built-in routines that enable a very wide variety of computations. It has specific applications which are collected in packages referred to as toolbox. There are toolboxes for signal processing, symbolic computation, control theory, simulation, optimization, and several other fields of applied science and engineering. Next is how to install the student edition of MATLAB. The professional and student editions of MATLAB are very similar. Student editions are available for Microsoft Word, Microsoft Windows, Mac operating system version 10, and Linux operating systems. It can be purchased from college bookstores or online from the MathWorks at www.mathworks.com. The MathWorks packages its software in groups called releases. New versions are released every 6 months. The release number is the same for both the student as well as professional edition, but the student version may lag the professional version by several months. Toolboxes other than those included with the student edition may be purchased separately. The biggest difference between the professional and student editions is the command prompt. Next is how to solve various problems in engineering and science using MATLAB. So different authors may formulate their problem solving schemes differently, but they all have the same basic format. First, we have to state the problem. In this step, you have to draw a picture, which is often helpful in this step. If you do not have a clear understanding of the problem, you are not likely to be able to solve it. After that, you have to describe the input values, which are knowns, and the required outputs, which are unknown to you. So be careful to include units as you describe the input and output values. Sloppy handling of units often leads to wrong answers. You have to identify constants you may need in the calculation, such as ideal gas constant, acceleration due to gravity, and so on. If appropriate, label a sketch with the values you have identified or group them into a appropriate or proper table. The next step is to develop an algorithm to solve the problem. In computer applications, this can often be accomplished with the hand example. You will need to identify any equations relating the knowns and unknowns, and you will need to work through a simplified version of the problem by hand or with a computer. Our next step is to solve the problem. This step involves creating a MATLAB solution in our MATLAB software. Next step is to test the solution. This is the last step in which you have to check, do your results make sense physically? Do they match your sample calculations? Is your answer really what was asked for? And the graphs are often useful ways to check your calculations for reasonableness. If you consistently use a structured problem solving approach, you will find that story problems become much easier to solve.
Thanks for watching this video.